So, once again, good morning, and we are going to complete, I believe it is the last section that we have to cover, or the last two sections that we have to cover before you have a test in here. So on Monday, we do the test review, and a week from today, you will take test 1, okay? Everybody good? All right, so making sure that you're staying on top of your homework is the most important thing, and your quizzes, and go back and do practice problems. If you're forgetting, how to do some of these problems that we did early, if you were a little shaky on them, go back and review. A couple of problems a day never hurt, all right? So if you just pull back in and do a couple of those, practice them, you'll be much more prepared for the test. It's a good habit to get into as we go forward because the material does get harder, unfortunately, as we go. All right, so I want to start today on page 30. I believe it's where we are. We only have 2 sections to cover. There aren't as many examples in your book that I've given you as I want, so I've added, that's what I was doing, I just pulled some more examples for us so we can work some extra problems once we finish these, okay? Now, the first time is division by a monomial. If you have multiple terms in the numerator and you just have a single term in the denominator, this is a division problem by a single term. In other words, division by a monomial. And the best way to do this one is always to split it, to divide it up. Everything, each separate term in the numerator goes over that monomial, and then you just reduce each of them, okay? So the problem here is that sometimes they have negatives in front, sometimes they don't, and that always causes complications. I want to take example 2 and do it first, because it doesn't have the negative issue, okay? So if I'm splitting them up, I'm going to say, okay, I've got 24m cubed, and that goes over the denominator of 4m squared, and a plus will separate them. And then I've got 8m squared, and that goes over the denominator of 4m squared. And I've got another plus separating the next term, which is 24m over the denominator of 4m squared. Everything in the numerator, operations are in between, and denominators are all the same. Now, I got to tell you that sometimes I'm copying these down and my brain goes into another whatever else I'm thinking about, and I'm doing the same repetitive thing and I copy one of these down wrong. So I would just say check it. Once you have written it down, make sure you've written the correct denominator, the same denominator for all of them, okay? I know you hate fractions, but this is where fractions are your friends. In algebra, it makes life so much easier. Now look, the next thing you do is you look at how we're going to reduce them. Well, consider the pieces, right? 24 over 4. 24 divided by 4 is a whole number. What is it? 6. And then I consider the m's because they match too, don't they? I've got m cubed over m squared. I will subtract the exponents, and I'll get m to the power of 1. And then all I have to do is decide, does it go in the numerator or the denominator? And the numerator, why? Yeah, because that exponent was bigger. So it just came up m to the power of 1. Well, I don't have to write an exponent of 1, do I? Good, and it's in the numerator. There's nothing in the denominator, or rather there's a 1 in the denominator now. So it's a whole number, not a fraction. So we did that one. Check. Let's do the next one. We're going to separate it by addition. We're going to say 8 divided by 4, and we're going to say m squared divided by m squared over m squared. What's it going to be? 1. Just plain old 1, right? Anything divided by itself cancels. So this is 2 times 1, which is just 2, isn't it? Okay, so we're done with that one. And next, we got another 24 divided by 4. And now we've got m to the power of, and you can write the exponent of 1 in if you're doing this and you need to, write it. I've got m squared in the bottom, I've got m to the power of 1. I'm going to once again subtract the exponents. I'm going to end up with just plain old m, or m to the power of 1, but this time I leave it in the denominator. And that's my answer. 6m plus 2 plus 6 over m. Is that pretty easy? So division of any polynomial, doesn't matter how many terms I have, I'm going to split it into that many different fractions. And then I'm going to reduce each of those fractions individually, and I'm done. Now here's where it gets complicated. Look at the first example. The first example has negatives. Now, and every time you have signs that are not positive, you really need to watch it and be careful. And this one has a negative in the denominator. So this is what we're going to do. We're going to say first term, 3x to the power of 9 divided by negative 3x to the 5th. Okay, negative went there. This one, in between these two, is a plus. So I'm going to go ahead and put plus. I'm going to say 27x to the power of 6 divided by up. It's negative, so I got to use the negative every time, don't I? And then I go, wait a minute, there's a negative here and there's a negative in the denominator. There's a negative in both of them. Well, we know a negative divided by a negative is a positive, but here's how you can do it to just remember it. You can say plus that negative 18x cubed, okay? I ended up putting the negative up here. I separated it by subtraction just to clarify. And then I have negative 3x to the power of 5 down here. All right, as I go through these, I say 3 divided by negative 3. What do I get? Negative 1. X to the 9th divided by x to the 5th. You're going to subtract those exponents, and you get x to the power of 4. Where do you put it, top or bottom? So I got negative 1 x to the 4th. Now you know that that coefficient of 1 is not necessary, don't you? We could write that term negative x to the power 4, okay? Just saying, that's probably the way we would write it. All right, let's look at this next one. It's a positive divided by negative. You know that that's going to be a negative. So just go ahead. The operation separating them has now become negative instead of positive, okay? And now I've got 27 divided by 3, or 27 divided by negative 3 if you want, which is what? Yeah, and it's negative 9. I already settled the issue of the sign. It's a good idea as soon as you can figure out what the sign is to settle it so you don't forget. And then I've got x to the 6th divided by x to the 5th, so I'll subtract exponents again. I get x to the power of 1, or just old x, in the numerator. There's nothing in that denominator. This became negative x to the 4th minus x to the 9th, and now here let's do the third term. This one says plus negative divided by negative, which makes what? Positive. So I can go ahead and say, okay, plus. And I've taken care of my signs, okay? 18 divided by 3, guys, what is it? Okay, good. X cubed over x to the power of 5. How many x am I, what's the exponent going to be? 2. Does it go up or down? Down. It's just that simple. I don't think even my lab math will count it wrong if you put that 1 in as the coefficient, but you don't need it. For the next class, you really need to recognize it. If you don't, if you need to recognize it, okay? Good? Are you good with those? All right. This one's harder. I want you to try it on your own. You're going to split this into 1, 2, 3, 4, 5 different fractions, and you're going to reduce each fraction, and every single one of them you have to deal with this negative issue, okay? So try it. I mean, the best way to figure out if you know what you're talking about or not is to try it, right? Can you what?
Do you leave it as a fraction or?
You always leave these as fractions. Good question. Uh-huh, like that. Does that help? Okay, you ready? Try this one. All right, so if I'm taking this and dividing it into pieces, everything has to be over a negative 5r, and that's a red flag for me. So I'm going to say the first one, negative 45r to the power of 4 divided by a negative 5r. The second one is plus, so I've got 50r cubed divided by a negative 5r. And then I've got minus, so I'm going to say plus a minus, okay? Just because it helps me when I've got the negatives to deal with in those numerators. R squared divided by negative 5r, plus again, 24r divided by negative 5r, and plus 11 divided by a negative 5r. Okay, lots of terms. Negative divided by negative, I know it's going to be positive. 45 divided by 5, what was it? 9. This is r to the first, so I say 4 minus 1. And I get r cubed up in the top, right? Are we good with the first term, everybody? Okay, good. The second one, tell me, is this term going to be positive or negative? Good, so let's just go ahead and put it down. And I got 50 divided by 5, which came out to be? That's right. And so either way you want to say it. And then I had r to the first again, so I'm going to say 3 minus 1. This time I come up with r squared, and I'm going to put it where? Numerator, denominator? Numerator, right? It goes up wherever the largest exponent was. Over here, I've got a negative divided by a negative, which gives me, so that stays plus, right? 75 divided by 5, what is it? Good, thank you. And again, 2 minus 1 gives me 1. So I say r, and it's left up here where the bigger exponent was in the top. And now I've got a positive divided by a negative, so I'm going to get what? That separates those two. And I've got 24 divided by 5. What did you do with that? Yeah, it doesn't reduce, does it? So let's just make it a fraction. 24, 5, right? Because that's the correct way. What did you do with r divided by r here? They cancel out. There's just nothing there, right? All right, is this next term positive or negative? Negative, exactly. And is there anything else we can do with it? No. Yeah. Can't reduce 11 over 5, can you? And there's just r down there. So this is how we write it, okay? Those operations, the signs that used to be stuck down here in the denominator are no longer. We have combined them with whatever the sign was in the numerator, and we have separated it. They made the operation separating the terms. Are you following me when I do that? Okay? So we no longer have negative anything down here. We've simply moved those negatives out front, combined them with whatever the top sign was, and turned it into the operation that separates the terms, okay? Okay, so let's look at the last one, which is just the same thing, guys, but it's just formatted a little differently. Instead of putting all of this over 2a to the 4th t, they just wrote it as this big, huge polynomial divided by 2a to the 4th t, which is doing the same thing. So all you got to do is split it out and say, okay, this first one is 4a to the 10th t to the 11th divided by 2a to the 4th t, right? Okay, minus, and keep going. I'll go ahead and write this out. You go ahead and finish the problem. We ready? Kinda? Okay, I want to point something out to you, and I want you to pretend for just a minute that you are trying to explain this to a younger brother, sister, cousin, aunt, I mean, whoever, right? Somebody that is in your family or you know that needs to understand how to do these fractions. And all I need you to explain to them is how the signs work. Okay? That's it. All I need is how the signs work. Now, this problem right here was being divided by a negative, wasn't it? Okay, look at it. This one was being divided by negative. This one right above here was being divided by a positive. I mean, signs seem to be where we run into most trouble, so that's why I'm focusing here for just a minute, okay? So if I'm dividing by a positive, then all of the signs that were in the numerator stay the same. I mean, does it change a sign when I divide something by a positive? So there was a plus here and a plus here. This one was plus, this one was plus, this one was plus. Look at my answer. Plus, plus, and plus, right? Okay, look at what happened with this one. So this one was dividing by a negative. What happens when you divide by a negative? Well, whatever the sign is, it is now the opposite. If you take a negative and divide by a negative, it's positive. If you take a positive and divide by a negative, it's negative. It flips the signs, right? I mean, that's easy to understand, isn't it? So look, first term was negative, it's now positive. Second was positive, it's now negative. The third was negative, it became positive. The fourth was positive, it became negative. Look, I mean, couldn't you have just looked at this thing and figured out those signs without ever doing any math at all, right? Okay, you should probably do that. And you would tell that younger brother, sister, cousin, you know, whatever, that this is how you do it first. You figure the signs out because that is where you're going to go wrong most of the time. The signs are the most confusing thing. If you got the signs, you know, sometimes that's it. In this class, this is where I see the most mistakes. So let's do these signs, okay? This one is being divided by positive. Therefore, what am I going to do to all four of these signs? This one, by the way, doesn't say anything, so it's positive, right? I got a positive, a negative, a positive, a negative. I'm dividing by positive. What do you tell them? What do the signs do? They stay the same. I could come down here and I could say negative, positive, negative, and of course this one's positive because I'm not writing it. And I'm through worrying about signs, okay? Up here, all I would have had to do is say, well, flip them, right? This was negative, write positive. Opposite of the sign. Is that what you would tell them? I don't know, use your own words. Think in your head what you would do to explain this to somebody. That's your best bet for understanding it, okay? If you can explain it to somebody else, you know it. That's the bottom line. If I can teach you something, I understand it thoroughly, you know? As opposed to, have you ever had anybody try to teach you something who really just knew how to work it themselves? I know how to do this, but I don't know how to explain it. Well, you don't really understand it if you don't know how to explain it. So this is what you need to do. You need to be able to explain this stuff to somebody else. And it's a good exercise for you. If you have anybody who listens, and the dog works really well for that too. They listen really well, guys. I'm telling you. Tell somebody what you're doing. Talk through the math. It's about to get harder. Your best bet for understanding how to work these problems is if you can explain it, okay? Not just, okay, I worked 4 problems and I got 2 of them right. I must know what I'm doing. Most of the time, that's not true, okay? All right, so 4 divided by 2, a to the 10th divided by a to the 4th. And I'm going in the numerator until you guys tell me not to. This is t to the 11th divided by t. What do you get? T to the 10th. And everything was in the numerator, wasn't it? Over here, again, 4 divided by 2, right? A to the 8th divided by a to the 4th. And 9 minus 1, right? 18 divided by 2. What'd you do with the a's? They're gone, right? What about this t to the 5th over t? And now we say 8 divided by 2. And we say a to the 6th divided by a to the 4th. And t squared over t. Just t. Nothing in the denominators. Everything turned out to be whole numbers. But you know from the past it doesn't have to be, right?
Can I see your first example?
Sure. Yeah, yeah.
Good negative 2, so you put that.
I don't ever do it that way. I say 5 minus 3 gives me 2. Where do I put it? Wherever the largest exponent is. Largest was on the bottom, I put it on the bottom. Negative exponents confuse more people than not.
Okay.
So however you're thinking about it, if you're saying always, subtract the top, bottom from top, and if it turns out to be negative, it has to go down. If that makes sense to you, that's fine. But I always say, okay, subtract the smaller one from the bigger one, and you leave whatever you've got. The answer goes wherever you found the bigger exponent. Since it was on the bottom, that's where it went.
Okay, but if we would have put the answer as 6x to the negative 2.
Remember that you cannot finish a problem with a negative exponent.
Okay.
That's the thing you have to remember. Negative exponents have to be resolved. Okay? All right.
Last one, sorry.
Th-
Where
th-
the 9 became 9, if you left the A there, that's wrong, right?
Where are we?
The last example we just did,
This one.
the bottom one.
The last one.
The-
Number 4.
Oh, okay, so if I left what? Oh, here? Yeah. Because you would be saying that one of these A's was bigger than the other one, and they're exactly the same, aren't they? There's 4 A's, A times A times A times A up here, A times A times A times A, and they all cancel each other. Yeah, you can't leave it. What you would see, okay, this might be where you're messing up. If I subtracted exponents, I get A to the power of 0, okay, wouldn't I? Well, anything to the power of 0 is what? 1. The number 1, not the exponent 1, the number 1. So A to the power of 0 is really 1. Well, and then we multiply 1 times 9, and that just gives us 9. Does that help to think about it that way? Otherwise, they just cancel each other out, and you think about it that way, okay? All right, let's look at something else. Now, this was easy because we are simply dividing by a monomial. We're dividing by a single term, and this is going to be different when we go into these next problems. We're going to be dividing by 2 terms, okay? These are the hardest polynomial division problems that we're going to hit in here, all right? I don't know if you remember synthetic division. How many of you have worked synthetic division before? Yeah? You remember the rules for it? I mean, the rules are kind of written here at the top for you, but they're a little bit shaky. Let me ask you this, because I have a daughter who teaches high school math and calculus and pre-calc and a lot of stuff, and she says, I never teach synthetic division, I teach it the other way, I teach long division. Okay, did you learn it that way? We have had this argument for years now, and neither one of us is ever going to budge, so therefore I'm asking you, which way did you learn it? Did you learn long division when you did these two, or did you learn synthetic division? If you know, tell me. Anybody learn long division of these? Is that, yeah?
We did the long division first, and then we did synthetic.
Did you by any chance go to Treasure Coast High School?
Yeah.
Okay. Did you have my daughter? Maybe?
I don't think so.
Okay. Anyway. All right. Long division? Okay, you learned it both? Okay. I'm going to go over it both, but you're going to pick which method you like, okay? Because it's not, it's not that one is right and the other one is wrong. It's one sometimes confuses more people than the other one. I don't know which. Learning the rules and memorizing the rules for synthetic, sometimes people mess up when they're trying to do that. So let's just try this, okay? Let me get this straight here where I am, because I had some notes on this page I didn't want to mess up. I did want to give it to you. So what I've got here is long division wise, I would say x minus 4, and I would go divide it into whatever this is, which is 4x cubed minus 9x squared minus 8, okay? So that's all I did. And you know how you do long division. You find out what the first easiest part of it is, the first part of this number, and how is it going to go into the first term. But you have 2 terms, so you're going to start your answer over that second term, right? That's where I'm going to start my answer. So I'm going to say, okay, so if I wanted something times x to be 4x cubed, I would say, okay, 4x squared, wouldn't I? And just to check and make sure you're on the right track, you're putting x squared on top of x squared. I messed up here. I've got to do one thing for you. This is a bad first example problem because it has x cubed, x squared, and then it does not have an x term. Well, guys, when we're doing division, either way, you've got to follow the exponent, the variable terms, all the way to the bottom. If we don't have an x term, we have to put it in. Instead of minus 8, I've got to put in plus 0x, and then I can say minus 8. Does this sound like something you've done before? Okay, so I just checked myself, x cubed, x squared, x, and then if I have a number, a numeric term, it follows. Everything has to be in order. Either system, either method you use, you've got to do that, and that's a 0. Sorry that I...
Why do we put the 0 there? Because there was no x?
Yeah, because there was no x term, and we have to have a space for it even if we don't have it, even if we have 0x, okay? All right, so I've got 4x squared, going back to what I was doing. I say 4x squared times this negative 4 is going to give me a, what is it, negative 16x squared, right? And then I say 4x squared times x. Well, that gives me 4x cubed. Now, that's what I was looking for, was to match this 4x cubed, wasn't it? And I'm going to subtract these from the top numbers, the first number. So when I subtract, I change the signs. True? This one was negative, it became positive, that's negative, and then I can combine them. Well, these are going to cancel, aren't they? That's my goal. And then I'm going to say 16 minus 9, negative 9 plus 16, and I end up with 7x squared. And I bring down the next term. If you're doing long division, you just bring down the next number. I'm doing the same thing, right?
Can you start over?
Can I
Just
start?
explain what you did, because I'm confused. How do you know if you're going to do the x first or the negative 4 first when you're dividing it?
When I'm dividing it.
So go back to the top before you put the 4x squared on the top as a...
Well, I set all these things in order from the largest exponent all the way down, and I had to put in an x term because I didn't have it. You got that, right? Okay, good. So now I've got x minus 4. I take this first part of it, x, and I look at the first number and I say, what is it going to be times x to give me that number? Okay, what would it take? Well, I'd have to multiply x times 4, and then I'd have to multiply x times x squared. That would give me 4x cubed. Okay, I don't write it over this because I've got a two-part polynomial. I write it over the second term. I'm multiplying, it ended up being an x squared that I multiplied. Just to check yourself, I'm over an x squared, aren't I? And that kind of is a way to guide yourself too.
So if it wouldn't have been an x squared, you got your answers wrong?
Yeah,
Okay.
I believe I'm hearing you right.
How did
Okay.
you get the positive 16? Is it only because you were subtracting a negative
Well,
underneath?
yeah, that's exactly right. I said 4 times negative gave me the negative 16x squared, right? And then I said this one times x gave me exactly what I have. But these terms have to be subtracted from the above terms, right? So change the signs. It was negative, it became positive. This was positive, it became negative. Making sense? Long division's not something you've done since they handed you a calculator, is it? Yeah, I know. This is why I don't usually use this. But that's okay. We're going to get it. Okay, so let's go down and say, okay, next I'm looking at this number, the first part of it, 7x squared. I'm still dealing with x. What do I multiply times x to give me 7x squared? Okay, so I'll see a positive 7x, right? Good? Now let's do the multiplication. We say 7x times negative 4, negative 28x, right? And then we say 7x times x, 7x squared. Well, that's what we were hoping, right? Now look what we've got. Now we have to subtract those from that number above them, so we change the signs. Positive becomes negative, negative becomes positive, right? Draw your line, and let's combine them. Well, once again, first terms cancel, which is the whole purpose, right? And then we have to say, well, 0 plus 28 gives me 28x's, right? And bring down the next term, the next polynomial, our monomial, rather, negative 8. Now I have to look at it again. X times what is going to give me 28x? So I'm going to multiply times 28. Now this one's not easy. I would pick up a calculator and say 28 times negative 4 Anybody?
7? Oh, multiply.
Yeah, multiply.
Negative 105.
That's what I got. Everybody good with that? And then I say 28 times x to get my 28x. And then I change the signs because I've got to subtract these terms. And I go 112 minus 8, 104. And there's nothing to bring down. That becomes my remainder, right? You remember long division a little bit now? Okay, so that's my remainder. How do we write a remainder? Well, we say it's 104 over whatever we divided by, which was x minus 4. And that's the answer. 4x squared plus 7x plus 28 with a remainder of 104 over x minus 4. Yes. You okay?
Well, you have to split the signs because you have to change it to subtraction. You only put the signs on the bottom.
Yeah, only on these bottoms because we're subtracting those terms from the top term above it. And when you subtract anything, you know you flip the sign, really. That's what you're doing. Okay? Yeah.
With the remainder, do you like add it to your answer or multiply it to your answer?
It's
Like, how do
just
you
part
write
of
it?
the answer. You would say, I would, when you're saying it, you're going to say and 104 over, it's a separate, this is one term, two terms, three terms, there's the fourth one. But it's not plus it or anything, it's just the remainder.
Well, we have to do that in my lab math.
Mm-hmm.
Would we write like REM?
It'll give you a way to do it, and if I have time, I'll check and see what their way is, okay? It may be that they want you to put a plus in there, plus 104 over, because that would be the same thing. It's the remainder. Okay? Now, let's do synthetic division. These are the rules that I've got written for you at the top, and they're just confusing to read them unless you know how to work them. So what it says first things first, always with these problems, is you have to write this thing with all the exponents pieces there. All the variables have to have exponents all the way down to 0, right? So what I've got here is I had 4x cubed, 4x cubed minus 9x squared minus or plus, there's the one that's missing, minus 8. Write it out first so that you don't leave out this part, okay? The missing piece has to be filled in. I'm going to divide that by x minus 4. So I'm just rewriting the problem so that it has all of its pieces, right? Okay, now for synthetic division, I don't really want to write the variables. I'm just going to write the coefficients in front of the variables, okay? In other words, I'm just dealing with the numbers. I'm going to say 4, and then I have minus 9, and I have a 0. You can put a plus 0 if you want to, and I have a negative 8. Just the coefficients, okay? And then instead of making it look like division, let's do this and make the division house backwards, because that'll show us that we're not exactly doing division here, we're doing synthetic. And the next thing I need to do is say, what are you going to divide by? Well, I'm not dealing with the variables, I'm dealing with just the number, right? See that negative 4? You want the opposite of that negative 4. So what do you want to divide by? Positive 4. It's always the opposite. If that thing had been positive, I would be dividing by a negative, okay? Now, this only works, listen to me, if the coefficient of this binomial here is 1. This will not work if I had 2x plus 6, 2x minus 4, 3x anything. It's not going to work. You can only do synthetic division like we're doing it if the coefficient in front of that x term is a 1. That's the only kind of problems you're going to have in this class, okay? So this is why we can do it. All right, so now the first thing you do with synthetic is you don't do division first. You simply bring down the first number, okay? And now you start the multiplication. I say 4 times 4, and I get 16. And then I combine those terms. Well, I had a negative 9 and a positive 16, so what am I going to get? 7. And then I say 4 times 7 gives me what? It's a positive 28. I combine 0 and 28. And I say 4 times 28. Yeah, you've done it before, haven't you? And then I say 112 minus 8. What does it give me? These numbers should be sounding a little familiar to you. Okay, well, we've got numbers. What do we do with them? Well, you see how we had an x cubed as our first term up here? Subtract 1 from the exponent, that's where you start. In other words, if we started with x cubed, we now have 4x squared. Plus, because that's a positive 7, right? 7, well, let's go down by 1 exponent. Just keep going down. 7x. Plus 28. Well, x to the power 0 is just 1, so there's no x in this one. Here's our remainder, isn't it? It is not over 4. It's still over. Go back to the original problem and find out what the denominator is. And now look at your two answers. See this one and this one? Which one do you like? Synthetic? Okay. I mean, I tell my daughter this all the time. I've had this discussion with her before. No, there's no reason to teach synthetic division. Just teach them long division. Okay. If it's me, I make fewer mistakes doing this than I do doing that, okay? I just do. I don't know what you want to do, but okay, I'm going to do this.
But how do you remember that? I know why you know because you're the teacher, but how would we remember that 104 was the remainder?
Okay, the reason I know is not because of the teachers, because I've done it so much. Okay. This is how you remember it, is you're going to practice, okay? And you will remember that after. See, I've run out of x's, right? Okay. So there's an x term, and then this term is simply a number term, and now I can't have two just plain old number terms. This one is the remainder. Okay?
If we would have never did the long division first, I would have added the 104 to the 28 and made that my answer.
But you won't do that now.
Right.
Okay.
So is the last term always going to be the remainder if it doesn't cancel itself out?
If you have an x square or whatever, and you come down to the x term and then you have a number, it's not a remainder. But if you have something past the number, it's the remainder. So you always
just have the two numbers.
You never have two numbers sitting there. The very last one, if you have two numbers at the end, the last one is a remainder. I think if we got a couple more.
Like the long division.
You like the long division?
Yeah, because there's too many
You're winning my daughter's case for her.
There's too many okay, so what if it was x squared minus 4 in the denominator? Could you not use this synthetic at all?
If it was x squared minus 4, you can't do this. You've got a single x variable here, right? And it has to have a coefficient of 1. This is a very, very specific set of problems that we can work with this.
Will we not get in trouble for get it wrong if we just do long division?
No,
Okay.
as long as you don't make mistakes.
Okay.
It works the same.
Prone to mistakes.
It's what you prefer is what it is, okay? So let's do the next one. We'll do it both ways, all right? All right, so I have this really long problem, but the first thing let's do is just check it. X to the fourth, x cubed, x squared, x number. It's fine, isn't it? It's got all its pieces. It's in the right order. So I'm going to put it down for long division. I'm going to go 5, x to the power 4 minus 23, x cubed plus 14, x squared minus 9x plus 4, and I'm going to say divided by x minus 4. Now, I know this is a two-term polynomial, so I know that I'm going to start off, and you might just want to do that, start off with the first answer. First part of my answer is going to be over this second term, right? Okay, and think about if you were doing two division into 15, a two-digit number into a 5-digit number, you would start off with the second one, right? Okay, so I'm going to say, what does it take to multiply times x to give me 5x to the fourth? 5x cubed is where I start. And then I multiply. I say 5x cubed times that negative 4. Well, that's a negative 20x cubed, isn't it? And I say 5x cubed times x. 5x to the power 4. Now, I have to subtract these two terms from the top one, so I will change their signs. Negative, positive, and now I can combine them. These two cancel, and this is like saying negative 23 plus 20. It's going to be a negative answer, isn't it? Negative 3x cubed. Oops, let's see if I can get this up higher.
We don't do anything with the exponents when we're subtracting them, it just goes in.
Well, no, because you're subtracting like terms, aren't you? You're not multiplying exponents, or that's only dividing exponents. You're just subtracting the coefficients in front. And they have to match for you to do that, and these are alike terms. So now we're going to bring down this next term. And I'm going to say, okay, looking at the first term down here, it's a negative. It is negative 3x cubed. What do I multiply times x to get me to a negative 3x cubed? Okay, good. Negative 3x squared. Let's practice and see if that works. Okay, negative 3x squared. Negative times negative. Well, that gave me a positive, what, 12x squares? And this is going to give me a negative 3. And this is where you check yourselves, right? Did it match? Yep, these match. Change the signs to show that you're combining. And this plus, this time I have to, instead of just, I have to kind of scratch it out and put a negative there, don't I? Now these canceled, and I have 14 minus 12 x squares, right? Bring down the next term. So, what do I multiply times x to get 2x squared? 2x, positive, right? 2x times negative 4. Well, that's positive times negative. It's going to be 2 times 4, and I have to multiply x times 1, really. And then I say 2 times, 2x squared. I'm trying to say 2x times x gave me my 2x squared. They match. Change the signs to subtract them. These are going to cancel, and this is going to be a negative 1, a positive 8. What do you end up with? Negative, and I'm going to go ahead and put a 1 down there. Bring down the final term. And what have I got? Well, what times x will give me a negative 1x? Okay. So let's try that. Negative 1 times negative 4, right? Negative 1 times positive x. Now I want to subtract those terms, so I change the signs. This one becomes positive, and that positive becomes negative. And what happens? Yeah, there's nothing left. You can put 0 if you want. So what's the remainder on this one? There is none. Right, it's 0. Okay, so my answer, 5x cubed minus 3x squared plus 2x minus 1, no remainder, right? Are you okay? All right, synthetic division, anybody? All right, let's see. We've already got this problem. This is what goes under the house, right? Or inside it. So I'm going to just write down the numbers. I'm going to say 5, negative 23, 14, negative 9, positive 4, right? Did I get them right? I'm going to build the synthetic division. And I'm going to go, what do I divide by? Not negative, the opposite of it. This time, yeah, that's why synthetic division, you have to memorize the rules, everybody, okay? We just write the coefficients down, keep the signs with them, but when you go to divide, you take the opposite of whatever that is. If it's negative, you take positive. If it's positive, you take negative. Now, first step. Exactly. Bring down the 5. Now, you don't multiply first, you just bring it down. And that way you know what to multiply times, right? 5 times 4. Combine these two. What do you end up with? 4 times negative 3. Combine these two. What do you end up with? 4 times 2. Combine these two. What have you got? 4 times negative 1. Combine them, and what do you have? So let's look at what are these answers. Well, we had, the problem started with x to the 4th, so we're going to go one less than that. We start with x cubed, and we go down. X squared, x, and the numeric term. Check. We should have the same for both. Yes? Are you still stuck with synthetic, or are you liking the long division better now? Synthetic? I'm going to take a vote. I'm going to show it to her when she, anyway. We ride bikes on Thursday. I'm going to have this argument again tomorrow.
I mean, synthetic is simpler, but like you said, you have to memorize all the rules, and unless you're
You
committed
do.
to that.
That's her argument too. You're exactly, this is what she says to me all the time. She's not wrong. I mean, you're not wrong. It's just a preference. Whatever you like, you just practice it until you are, proficient. You've got to get a practice into your proficient so that you know if you're making a mistake or not, right? And sometimes I've seen people do it both ways just to check themselves. Okay, let's do 2 more. That's all I've got on this thing, and I've got some extra problems for you, so don't start putting your book away if we finish this early, okay? Let's try this one, though. Something is wrong with this problem. What is wrong with this problem?
They're not in order.
They're not in order. So we've got to start with the largest exponent. Let's rewrite this thing. I want 5x cubed to go first. I've got to have, if I'm going to divide, I've got to have an x squared term, but I have one, so I'll use that one. It's a positive 8x squared, isn't it? Now I need an x term, and I have one. Negative 8x. And then the number term, which I can have or not have. It simply doesn't matter if I don't have one, okay? But I do have to have all the variables all the way down to plain old x, right? Something to the power of 1. And I'm going to divide by x plus 1. Now, synthetic first this time, okay? I'm going to write the numbers down. Here's 1, a 5, 8, negative 8, 8. And I am going to divide by what? Exactly. You guys with me? The opposite of that this time is a negative. Well, that complicates things a little bit. Every time I stick a negative in there, my life gets a little more complicated, right? So this time, I bring down the 5, and I multiply negative 1 times 5, and I get negative 5. Combining 8 and negative 5, what do you get? 3. Negative 1 times 3. This time when I combine negative 8 and negative 3, I have, and this time now I'm going to say negative 1 times negative 11. And for some reason, I have done this several times and made that 12, okay? Just saying, if I see 1 and 11, I want to add, not multiply. Just be careful, because if I'm doing it, somebody else is thinking the same way. So, positive 11, when I combine these two, what have I got? All right, let's see what they are. This one is 5x what?
Wait a minute. We're just either adding or subtracting depending on the sign of the answer? It's not that we're always subtracting here?
Nope.
Okay.
We are just adding or subtracting depending. We're combining instead of, think about it as combining these two instead of what long division does, which is always subtract, okay?
Okay, so because that was positive, yeah.
Mm-hmm.
Okay.
So I started with x squared. This is going to be 3x. This is going to be 11. What's the 19? It is. And you're going to put that remainder over x plus 1. Do you want to see long division? No?
We don't have,
You're okay?
so
You
as
can,
long as you do it, if you do it both ways, you should get the same answer.
you should get the same answer. You better get the same answer. Something's wrong. Okay,
On the bottom part, so you start bringing down the exponent.
okay.
Can you go over
Yeah.
that?
This largest term is x cubed. Subtract 1 from the exponent and start with that one, x squared. And then go down by 1. X squared, x to the power of 1, no x term at all. The next one, if I have one, is a remainder.
So it's always that way.
Always. Yep. And the reason it's always that way is because we had no gaps up here, did we? X cubed, x squared, x number. I mean, if we had had a gap, we would have put in 0 times x squared or whatever, okay? And that way this always works. All right, do this one. It's not hard. Do it either way you want to. It's already in the right order. It's got all its pieces, right? This is an easy one. You should be able to get to the answer quickly. And I'm just going to go ahead and tell you the answer to this one is x plus 6. Just saying, okay? Do the division any way you want to. Did you get it? Yeah. And then get a piece of paper out. And no, I'm not giving you a pop quiz, okay? That always sounds like I'm giving you a pop quiz. Get a piece of paper out or write somewhere on that page, but really piece of notebook paper after you finish this, because I've got a couple more that I didn't put in our book, and I think I'm going to add to this section, okay?
You said X plus 6?
X plus 6 is your answer. I'm going to go ahead and work it for you. I already told you the answer, but let me go ahead and work it.
Panicked at first.
That's the hard part, isn't it?
Yeah.
I thought it would make you think, if I didn't tell you. Coefficient of those variables is 1, isn't it? You got that part? If you got that part, you're home free. That was it. Okay, is that good? Are there any questions on this one? Did you get it? Are you doing long division on it?
Oh, no, I did long division on the last one, just to
Okay,
make sure.
so you got it. Okay,
Yeah.
good. I want to make sure you're good with that.
So how you said in this class we'll only have
You're out.
plain X.
Mm-hmm.
In the future, there will be a number in front of X.
College algebra changes things a little bit, but you have the possibility. Depends on how far you go. Are you going into calculus?
I don't know. I'm just going with it.
You're just going, okay. Pre-cal. Ready? Next problem. Okay, guys, which one would you like more practice with? Do you want practice with dividing by a single term, or do we feel really good about that one? How are you with this? Everybody, give me thumbs up if you think you got that part, okay?
I think we can do another one of those.
Okay, you want to do one more?
Yes.
Okay, we'll do one more of those.
With a negative.
Yeah, with the negative
All right.
exponent.
Oh, okay.
A negative,
A negative denominator.
negative denominator, right? Or you're talking about here with an, okay, let's see. I'm going to have to make one up. But I can do that real quick. Here's your problem, all right? The problem is 5x squared y squared plus 25 xy squared minus 10 y squared, and all of this is divided by negative 5, oh, you probably called me, thank you, x squared. Guys, this is my husband, Bobby, and he is bringing me tests. Anyway, so now I'm going to divide by negative 5x squared, right? X squared y, sorry. So I'm going to take each one. And I'm going to just decide on the sign before I do it. Look at this. Can't I make that management decision before I ever do anything else? First term's going to be negative, second term's going to be negative, third term's going to be positive, right? Settle that issue, because once you start doing division and combining and doing other things, for some reason that simple negative can escape your attention, okay? All right, so now I'm going to say this one divided by that 5x squared y. I stuck the negative out front. This one, I stuck the negative out front of it too. And this one, I put the negatives together and made it positive, so I don't have to worry about the signs anymore. Does that make sense? Now we're going to cancel 5 over 5. Well, this one's still negative, isn't it? This time it's still going to be negative. This one's going to be positive. 5 over 5 cancels, x squared over x squared cancels, y squared over y to the power of 1. All I got left here is y, right? Okay, 25 divided by 5. X over x squared. Where's the x going to be? Bottom. Y squared over y. Y is left in the top. What am I doing? I'm subtracting the exponents and I'm leaving what is left wherever the larger exponent was. Next, 10 divided by 5. And then I've got, well, there's no x's in the numerator, so there's nothing I can do about that one, is there? But I've got y squared over y, just y. Okay, how'd we do? They what? No, it's okay. You get practice. There's lots of practice coming your way. And this is on video. Now, Echo's working again. So this is, you can play again. Okay? So shall we look at a synthetic division or a long division problem? You got the synthetic and you want to look at long? Okay, wait a second. I'm picking the hardest one. Hang on a minute.
Something from the test.
Coming from the test. That would be nice. Okay, I got 8x squared minus 8x plus 9. Well, it could be coming from the test. Who knows? 3x cubed divided by x plus 2. Okay? The first thing you got to do is rewrite the thing, right? No matter what kind of division you're doing, this thing is in the wrong order, and you've got to make sure you've got one of every term, don't you? So we're going to start with the largest exponent, and we're going to work our way down, making sure that we have one of everything. If I'm doing synthetic, those are my numbers, and that's my divisor, right? This is really quick, so I'm going to go ahead and do it. It's 24 plus 9, somebody. 33, thank you. So we start with one less exponent, right? I had an x cubed as my first term. My first term is now x squared. So this term must be just plain old x. This one must be just a plain old number, and that one has to be a remainder over whatever I was dividing by, which is x plus 2, right? I know you wanted to see long division, but I have something else I need you to make sure you understand, so I'm going to run through one more problem, and then I'm going to run out of time. Look at this one. Are we good with that one? Did that one happen pretty quickly and pretty cleanly for you? Are you okay? Yes? Okay. All right, so let's look at this, because I need you to see this. Here's another problem. It's negative 7x plus 6x cubed plus 5 divided by x minus 2. Now, I need you to write that problem again for me the way that it should be written for synthetic division or for division of any kind of problem. What's your first term going to be?
6x cubed.
What's your second term going to be?
0x squared.
Thank you. You see it? This is where I go wrong too. I don't have an x squared. Right? I got to put one in. It's got a coefficient of 0 because it simply doesn't exist in the problem. 0 times anything is really 0, so that's the x squared term. Is there an x term? And then I have a number, right? If you do whatever kind of division you do, long division or synthetic, that is your first step, okay?
So 0x is mandatory. You have to have a placeholder?
Yeah, you have to have a placeholder. You have to have something for that x squared term that was missing. I mean, sometimes, look at this one, guys. Sometimes you'll have something like this. Negative 16x to the power of 5 minus 2. Fix that one. Fix it. Oh, divided by. Fix this one so that you could do division, okay? What's the first term?
Negative 16x to the 4th.
What's the next term?
0x to the 4th.
What's the next term?
0x to the 4th.
And the next term?
0x squared.
And the next term? And finally, you see it? As ridiculous as that may seem to us, we got to put in a placeholder for all those missing terms, okay? Are you with me? I should say extra credit. Work these problems. Bring them back to me, okay?